Few sights are as beautiful as the millions of stars stretching across the southern sky. Many thousands of years ago, a hitherto insignificant star exploded and flared up. Now its light has reached us, and it has become bright enough to be seen with the naked eye. For astronomers, it is a fantastic experience. They enjoy the rare privilege of watching a supernova, the death of a star in a gigantic outburst, releasing in a single second more energy than 100,000 million normal suns. Nothing like this has been seen with the naked eye for nearly 400 years. Every telescope at the European Southern Observatory turns to watch this extraordinary sight. To the many scientists who work here, this event marks a high point in a long series of exciting astronomical discoveries made at a breathtaking pace these days, thanks to the application of sophisticated modern technology. During the coming hours, days, weeks, even years, they will study the supernova and its effects to gain new insight into the life and death of stars, into the physics of elementary particles, and to learn how the elements in the universe are fused. Intensive work goes on at the Silla Observatory all through these nights, as astronomers strive to capture all the details of the supernova. They know that in all probability they will never have another chance.
Hello? Hey John, how are you? Oh, fantastic. We got one spectrum from 1.4 to 2.4. I'm doing now another.
Here on a remote mountaintop in the Atacama Desert in Chile, one of the world's largest astronomical observatories has been built. Between the Pacific Ocean and the majestic Andes range, nature has created a remarkable climate with clear, calm skies, so that conditions for studying the sky are exceptionally good. La Silla, which means the saddle, is the mountain ridge upon which the European Southern Observatory, ESO, has been set up. There are 15 telescopes in all. ESO is a unique international European organization supported by the Federal Republic of Germany, Belgium, Denmark, France, Italy, the Netherlands, Sweden, and Switzerland. Others may join soon. The 8 member states have between them 80 universities or institutions for astronomy, with some 800 staff astronomers between them and as many graduate students, all involved in astronomical research. Individually, they would not be able to compete with some of the large institutions in other countries, but gathered together by ESO, European astronomers are able to use the finest equipment available. It takes an organization as unique as ESO to coordinate that number of people, encouraging collaboration to further human knowledge through original research. Fellowships last for 2 years. Alliances and friendships develop, which can culminate in many years of research collaboration. The advantages for the participating countries and their astronomers are many. They can observe with some of the world's finest telescopes at one of the world's clearest sites for astronomical observations. They can exchange and pool their ideas and results. They can initiate major scientific and technical projects, which attract some of the best scientists and technicians in the world.
We're seeing light that is coming from the near side of the shell, which is moving towards us. Okay, that's what I got.
that I have been
Hi, how are you?
As the meeting place for astronomers, ESO has also stimulated national research efforts and European collaboration among the scientists. All in all, ESO has had a profound influence on European astronomy. It was in 1954 that the first idea for a combined Southern Observatory was seriously considered. There was nothing of the sort at the time. All major observatories had been in the northern hemisphere, so that many of the richest and most interesting areas of the sky were inaccessible. For example, the clouds of Magellan. The nearest important galaxies lie not far from the south celestial pole. After several years of discussion, ESO was eventually founded in 1962. Its aims were to encourage cooperation in astronomy and to provide scientists from all over Europe with an observatory which would have the most modern equipment. The Atacama Desert in northern Chile was chosen for the observatory site. The air at La Silla is calm, steady, and transparent, with a great number of clear nights. The humidity is usually very low, which is particularly important for some kinds of observations. La Silla stands 2,400 meters above sea level. There is virtually no light pollution. Santiago, the capital of Chile, is over 600 kilometers away to the south, and even the nearest town of any size, La Serena, is so far away that its light causes no trouble. The La Silla site, over 800 square kilometers, is extraterritorial, since ESO has special diplomatic status. While all observing is carried out here at La Silla, the true nerve center of ESO is its headquarters in Garching, near Munich in West Germany. At Garching, the long-term planning is coordinated, and the everyday running of the complex and sophisticated operation is controlled. Scientists and engineers meet here to discuss the results of their work, together with ideas for future telescopes and improved equipment. This is also where the Council, ESO's ruling body, meets twice a year. It is made up of representatives from the member countries and decides on the policies prepared and implemented by the Director General and his senior staff.
I noted that in the minutes myself. You will recall that last year.
But Garching is not only the administrative center of ESO. It is also a major research and technology center. There is a great deal of original work carried out here, as is demonstrated by the many astronomical and technical publications produced every year.
Well, I will be talking about work which I did on broad emission lines in intergalactic nuclei.
Scientists at all levels gather at ESO, from the graduate student to the distinguished professor. Some work for the organization for a few years, while others come more briefly to the many meetings and conferences.
Satisfactory in the sense that you can make them to fit the data.
In Garching, state-of-the-art computers and other devices help the astronomers to draw the best results from the data obtained at the telescopes. There is a plate library containing a photographic record of the objects in the southern sky which have been recorded at La Silla. Once the images have been taken at the telescopes, sophisticated and complex software is needed for final analysis. MIDAS is one of two powerful image processing programs written at ESO. It has been installed in over 100 scientific centers all over the world. With MIDAS, scientists can refine the raw data quickly and efficiently and use them for astrophysical analysis and interpretation. Another major development, making for greater flexibility, is the ability to operate the La Silla telescopes directly from Europe. This development has been spearheaded by ESO. Indeed, 3 of the telescopes at La Silla can already be run directly from a control room in Garching. This means that the astronomer has no need to make the long and time-consuming journey to Chile. This allows for maximum flexibility so that the particular program best suited to the prevailing conditions can be carried out. The control room at Garching is fully compatible with that at La Silla. The 2 are linked by satellite. When remote observing is not being carried out, the system can be used for normal telephone, fax, and computer communications. The Garching headquarters also houses the European Coordinating Facility for the 2.4-meter Hubble Space Telescope. The Space Telescope is a unique instrument which will contribute vastly to our understanding of the universe and complement the large ground-based instruments. Seeing conditions from space are always perfect. To keep telescopes at La Silla up to date, new equipment is needed all the time, and the telescopes are being steadily improved. The design of the new instruments is carried out in Garching, but much of the actual construction is contracted out to European industry, in optics, in electronics, heavy engineering, remote control devices, and the construction of special buildings. The skills of European industry are essential in the development of ESO, and there is the closest collaboration, which is of value to other sciences as well as to astronomy. Meeting the demands of ESO provides an enormous challenge for industry, and the resulting experience and extra skill helps European industry to reach and to maintain a leading role in important fields of high technology. There are extensive workshops and laboratories at the ESO headquarters in Garching. It is here that the new instruments are tested before being shipped to La Silla. One of these is the unique EMI, ESO multi-mode instrument, which is amazingly versatile and can provide almost simultaneously optical images and spectra of all types. In 1977, one of the world's largest and most powerful reflectors, the 3.6-meter telescope, was commissioned. It was designed to observe the distant regions of the universe, looking back in time more than 10,000 million years, and also to study stars in the furthest reaches of our own stellar system, the Milky Way galaxy. It has captured the sparse photons from newborn stars embedded in enormous interstellar clouds of gas and dust, and it has enabled astronomers to study the mysterious center of the galaxy. At La Silla, 15 telescopes are in operation at the present time. Rather different in type is the 1-meter Schmidt telescope, which is in effect a wide-field camera. It takes photographs on 30-centimeter glass plates so that each exposure covers a wide area of the sky. After the plates have been exposed, they are carefully examined and sent to Garching for copying. They form the heart of the Southern Sky Survey, a vitally important catalog which is used by astronomers all over the world. The survey has been carried out in conjunction with the UK Schmidt telescope at Siding Spring in Australia. It provides the first really comprehensive atlas of the southern sky. Many fascinating new objects have been found. For example, more than 15,000 hitherto unknown galaxies discovered on the plates have been scanned and classified in precise detail. Many objects much nearer home, such as comets and minor planets in our own solar system, have also been discovered. And now ESO's photographic laboratory is collaborating with the Palomar Observatory on a similar atlas of the northern sky. Another telescope at La Silla is the 1.5-meter Danish reflector. This plays its part in the general programs and has also been used for one series of unique observations. In 1986 came the return of Halley's Comet, the only bright comet we can predict, which caused great interest all over the world, even though it never became as spectacular as it had at past returns, notably in 1910. Halley's Comet goes around the Sun in a long, narrow path, and only when it is moving in the inner part of the solar system does it become active, with the ices in its nucleus evaporating to develop a head and a tail. At La Silla, the comet could still be followed, even when it had moved well over 1,500 million kilometers away from the Earth, and had become so faint that even the Danish telescope, together with the latest electronic equipment, could barely trace it. The latest addition to the mountaintop in Chile is the NTT, or New Technology Telescope, housed in a special building which turns with the telescope itself. The NTT has other special features as well. It is a compact telescope in a compact building, and this makes it relatively cheap to construct. It also increases efficiency as the design of the building reduces air turbulence around the telescope. Perhaps its most important feature is its active optics. This is a revolutionary mirror design. The heart of any telescope is its mirror, and the NTT's is very exceptional. It is extremely thin, only 24 centimeters thick, weighs only 6 tons, and if left on its own would twist and bend as the telescope moves, causing the image to distort. But a computer controls the mirror support, preserving the mirror's perfect shape.
Qui roule sur des toutes petites billes qui sont dessous, donc il n'y a pas de problème de flexion. Tu as les 3 supports fixes qui sont là et là.
The NTT went into operation in 1989 and has already proven to be even better than its makers had dared to hope. When you compare the photographs of the heart of a star cluster, Omega Centauri, taken with the NTT, with the ones from the older 3.6-meter telescope, it is obvious that the NTT images are much sharper, a clear demonstration that technology has been improved. Another new principle applied to the 3.6-meter telescope before being used on other large instruments at La Silla is that of adaptive optics. The disturbances in the Earth's atmosphere affect image quality, and to compensate for this, small mirrors capable of being very rapidly changed in shape by computer techniques are used in conjunction with the main mirror. Without this new technology, the weak image of a faint star jumps around. When adaptive optics is switched on, the star's image becomes brighter and more stable. All the telescopes at La Silla are in use on every clear night of the year, but not all the telescopes at La Silla are optical. Near the main domes, there is also the Swedish ESO submillimetre telescope, which started work in 1987. It is the only one of its kind in the southern hemisphere and is studying areas of the sky where the birth and death of stars can be observed and identifying and studying complex organic molecules in space. The next era of telescopes is well into the design stage. At a historic meeting in December 1987, the ESO Council embarked upon one of the most ambitious projects which modern astronomy has ever seen, the construction of the VLT. Strictly speaking, the VLT, or Very Large Telescope, will not be one telescope but 4, working together and giving as much power as a single 16-meter telescope would. There will be 4 8-meter mirrors. Each of them will make use of the new optical techniques pioneered with the NTT. The 4 components of the VLT can also be used separately, giving the whole program great flexibility. With the collaboration of European industry, the entire VLT should be completed by the end of the century, and the first of the 4-component telescopes should be working from the mid-1990s. The immense light grasp of the VLT means that it will be able to undertake research not possible with any other instrument. Some remote galaxies are very faint, so faint that only the VLT will be able to show them and investigate them. There is a continual search for the most distant objects accessible, the mysterious quasars, far more powerful than normal galaxies, which may lie very near the boundary of the observable universe. The VLT may well be able to tell us just where this boundary is. By embarking upon the VLT project, ESO is now at the forefront of astronomical science and technology, and is certain to remain there in the foreseeable future. Less than 40 years ago, all this was a dream. La Silla was a lonely, uninhabited mountain in what to Europeans was a remote country. All this has changed now, and here at ESO's great observatory, European astronomers are probing further than has ever been possible before. They take us to the outermost reaches of the universe, beyond current horizons, and thus provide us and future generations with a better understanding of the world we live in.